Hey, Algebra 2, happy Monday. So last week we started talking about long division and synthetic division. And so we're going to kind of continue that process today. So we're going to talk about the remainder theorem. So the remainder theorem states that when a polynomial, f of x, is divided by x minus a, the remainder is f of a. Okay, and I know a lot of us are like, what the heck does that mean? So I want to show you what that actually means. So as you can see, here's our polynomial. And we're already in standard form, so that's great. But we've got it divided by x minus 1. So in this case, we're going to be able to use synthetic division. Remember, synthetic division from last week. And if you didn't watch last week's videos, you need to make sure that you watch it, okay? So the first thing that we're going to do is we're going to change the sign of our divisor. This would be our divisor, which is going to be 1. And then we're going to write out the coefficients for all of these terms. So 2, 3, negative 17, and negative 30. And remember, with synthetic division, if any term is missing, you got to make sure that there's a 0. Like, let's say that this wasn't there, then you would have to write 0x here, and so 0 would be right here. So make sure that when you're doing your synthetic division, you set it up correctly. Otherwise, you're going to mess up the entire thing, okay? And a lot of us were doing that last week, so be careful on that, okay? And then there's going to be a little box over here as well. All right, so when we do our synthetic division, we're going to bring down that first term, and then we're going to multiply this times this number right here, and that's going to give us 2. 3 plus 2 is going to give us 5. We're going to multiply 1 times 5. That's going to give us 5. Negative 17 plus 5 is going to give me negative 12. 1 times negative 12 is going to give us negative 12. Add them together, that's going to give us negative 42. Okay, so let's say, for instance, your question says, hey, what's the remainder of this polynomial when it's divided? I think last week you saw it like this on the quiz. Let's say that they wrote it out like this. They were like, hey, take this and divide it by this. And then they asked, what is p of x plus negative 42 over x minus 1? Okay, we know that this is the remainder. So this p of x would be this stuff right here. Okay, if they had p of x right here and then they wrote all the rest of this stuff, then that would be asking you what's the remainder. Okay, so really quick, let's finish up this problem and kind of talk about what the remainder theorem actually means, because this, again, this sounds a little confusing up at the top. So if you were to solve this out, you would get 2 to the x squared plus 5x minus 12, and then you got this negative 42. Okay? So the remainder theorem says that if you took 1 and you plugged it in to this polynomial, you'll get negative 42. So let's test that theory. So we've got 2 times 1 cubed, and I'm just plugging this into this equation up here, or polynomial up there, plus 3 times 1 squared minus 17 times 1 minus 30. Okay, so let's simplify this. 2 times 1 to the third is 2. 3 times 1 to the second is 3. This will give us negative 17 minus 30. 2 plus 3 is 5. Negative 17 minus 30 is negative 47. If I combine like terms, I'm going to get negative 42. So I could find my remainder by just taking what the divisor is and plugging it into the original equation. Okay? All right, so let's try B really quick. Okay, so let's say that our question actually asked us to find the remainder of, because that's what this says right here. It says find the remainder. It doesn't care about anything else. It just says find the remainder. So all I've got to do is switch the sign of this guy and plug him into this polynomial. So 2 times 2 raised to the third power plus 3 times 2 minus 17 times 2 minus 30. And this is B. Okay, so 2 to the third power gives us 8. So 2 times 8. This is to the second power. And then we've got 3 times 2 to the second power, which is 4. We've got negative 34 minus 30. I'm going to simplify this. 16 plus 12 minus 34 minus 30. This will give us 28. This will give us negative 64. And if I combine these, and for my people who are like, I can't do all of this in my head, you can totally go into your graphing calculator, and that's totally okay. Please make sure that you have a graphing calculator for these, because I know a lot of us are not fans of doing mental math. So we would have 28 minus 64, and that would give us negative 36. Now you could have checked this by doing synthetic division. Okay, so theoretically this should be negative 36, right? All right, so let's try it doing synthetic division as well, because we should never get these type of questions wrong, because we have two different ways that we can do this problem. Okay, so let's change the sign, and let's list out the coefficients. Let's bring down that first term, multiply, add, multiply, add, multiply, add, and what's our remainder? Okay, so again, there's two different ways you can do it. If you're like, I don't remember this remainder theorem, I don't remember plugging it in, but the question might ask, hey, is this the remainder? Okay, or what is the remainder based off of this? So you've got to know this notation. Okay, so if it asks f of a, this would be f of 2, and you would take 2 and you would plug it into the equation. Okay, take a moment, pause the video, and I want you to find the remainder of c using the remainder theorem. So taking 3 and plugging it in. Okay, all right, so let's try it. 2 times 3 to the third power plus 3 times 3 to the second power minus 17 times 3 minus 30. Okay, so 3 to the third power is 27. 3 to the second power is 9. And again, I'm going to have to use my handy dandy calculator because, you know, mental math is tough. Minus 51 minus 30. And I'm going to plug this entire thing into my calculator so we can save a little bit of time. Make sure that you use your parentheses because otherwise it's going to mess you up. 3 times 9 minus 51 minus 30. Oh, that's 0. Okay, so here's a really important piece. If our remainder is 0, and this is like the big takeaway. If your remainder, and I would be writing this down, is 0, then your divisor is a factor slash a 0, a solution to the polynomial, or also called an x-intercept. So if I was to graph this guy right up here, it would cross the x-axis at 3. Okay, so if our remainder is 0, then the divisor, which is right here, means that it's going to cross the x-axis at 3. And that's going to come into play in our next unit when we start graphing these. And it's going to be a really big piece of that. So we want to make sure that we know the remainder theorem and understand what that actually represents, okay? All right, so these are for you to try. So pause the video and check your work. Okay, so let's check. And again, the equation, the polynomial that you would be using is this one right here. So we've got 2x to the third plus 3x squared minus 17x minus 30. Let me check and make sure that's right. Yep. Okay, so I'm going to plug in negative 1, 2, 3, negative 17, negative 30. Bring down the first term, multiply. Oh, but I don't even have to do any of that, right? I'm doing it the long way. I'm sorry. Okay, I can actually just change the sign and plug it in. So I'm going to do that because that's a little bit easier and I'm less likely to mess it up, right? Hopefully, maybe. All right, so if I simplify this, I'm going to get negative 2 plus 3 plus 17 minus 30. Then I'm going to combine my like terms. I'm going to get 1, 17 minus 30. So 18 minus 30. Okay, and that's going to give us negative 12. Okay, so that's my remainder for D. Okay, and then I'm going to plug it into the next one. So 2 times negative 2 to the third plus 3 times negative 2 to the second minus 17 times negative 2 minus 30. I'm going to combine my like terms, or I'm going to simplify, and that's going to give me negative 16, because this will give me negative 8 times 2, and then this will give me positive 12. This will give me positive 34 minus 30. I'm going to combine my like terms, negative 4, and then this will give me 4. Negative 4 plus 4 is 0. So negative 2 is definitely going to be an x-intercept of this polynomial. So we've got, from the last one, we've got 3 and negative 2 are zeros, x-intercepts, solutions to this polynomial. And the last one, negative 3, I'm going to plug that, and notice how I'm changing that sign, right? I'm going to plug that into here. Okay, so I'm going to simplify, and that's going to give me 2 times negative 27. I'm going to get 9 times 3, which is positive 27. And I'm going to use a calculator because y'all know it's late and math is tough. 2 times negative 27 that's going to give me negative 6. Cool? All right. So let's talk about the last little thing that we need to know. So factor theorem is saying that if x is equal to a is substituted in for x and the remainder is 0, then x minus a is a factor of the polynomial. So just like what I talked about a second ago, the fact that if it has a remainder of 0, then that is an x-intercept or a factor of that polynomial, okay? So use the above theorem and your results from question 1. Which of the given binomials are factors of this? Remember when we were like, oh, we know that negative 2 has a remainder of 0. Then that is a factor, okay? We also have C, which is x minus 3. So that would be, those are the solutions. Now, if it asks for factors, you would write this out as x plus 2 and x minus 3. Those are factors of this polynomial, okay? Using binomials, you determine where factors of this. Complete the division, divide by the chosen x minus a, and remember to fully factor your result in each case. Okay, so for instance, what we're going to do here is we already know that these are solutions, right? So they're going to give me a remainder of 0 every time that I divide. So I'm going to take negative 2 first and do synthetic division on this guy. Okay, so 2, 3, negative 17, and negative 30. And this is where synthetic division comes in real handy. So we're going to bring this guy down. We're going to multiply, bring the add, multiply, add, multiply, add, and that's going to give me 0. Okay? Now, instead of starting over this process, what you're going to do is now you're going to actually divide by the next factor, the next solution, which is 3. But you're going to keep these numbers. So you're going to bring the 2 down, multiply, add, multiply. And notice how this is now 0 right here. Okay, so now we're going to take this guy and we're going to go 2 exponents down. So this will be 2x plus 5. So now this is a factor of my solution. So we could solve this and we could get x equals negative 5 halves. Okay, so if I wanted to multiply this back out, this is what it would look like. I would have x plus 2 times x minus 3 times 2x plus 5. And if I multiplied that, I would get this as my solution. Okay.